All right, back to that Laplace transform of the unit step function and all that, the inverse Laplace transform. So remember that I had tried the expand thing and it sort of worked, but we were stuck with this. And so I took that denominator, the e to the minus 3s is the Heaviside or the unit step function thing. So I took that s cubed plus 4s squared minus 21s, 1 over that, and I did the partial fraction, and so I showed that, and that's what we get. And so it looks like all you can really do is brute force. I looked up things and it appears they don't have it. So let me get rid of that for a second. So I said, okay, so the unshifted part, the part without the heavy side and the little f of t minus c thing, that's just the inverse Laplace transform of this thing. And just to show that we can get that, I go down here and it does it just fine. So there was the Laplace transform. Here's the inverse Laplace transform. Yeah, that's what we were getting. But now we need to do the t minus 3 thing in the heavy side. And so that's where I go back to my x nasty. This time it's a small x because we're dealing with x of t. Here I do the Heaviside function of t minus 3 times that unshifted thing, but with t minus 3 substituted in for t, and then I show it, and you get what we got by hand for that part. Again, this is still kind of brute force stuff because, well, what I really have then is up here I have the first two terms of this for my solution, but then this bottom thing down here is that Laplace inverse up here. So I had to take these steps. So I'd have to put all that stuff together to make my full solution, but I have it here. So I have the initial part before t equals 3, and then the part after t equals 3 that goes adds on to that. And so we can do it with Sage. We can use these, we can work with these unit step functions or Heaviside functions. Now notice, here in defining the differential equation, I use unit step function of t minus 3. And then down here, when I wanted to print things out, I used Heaviside. Well, again, that's just a technology thing. I wasn't having luck up here using Heaviside, but Sage also has unit step, and so I tried that, and it worked great. Now I could try it. I might not have tried everything, but anyway, then down here, using the Heaviside at t minus 3 works just fine here in the sense that I got exactly what I wanted. Maybe I'll try that one more time. It could be that I got that something I was doing didn't work, and maybe, when I think about it, I'm not sure I tried t minus 3 because the documentation seemed to say you just use 3, but I thought I tried t minus 3, so I'll try it again just to see what happens. See if anything different happens than did before. Yeah, so see, it couldn't even, that's what happened before. Right in here, this part, it couldn't even take the Laplace transform of that Heaviside function. See, so up here, over here, again, it's stopping and not taking that Laplace transform of the Heaviside function. So for whatever reason, it can't do that, but if you call it the unit step function, it did it just fine. It gave us the correct Laplace transform. Right, there's the correct Laplace there's the correct Laplace transform, and it worked all the way down until we needed the inverse Laplace transform, and then it didn't know what to do, and so we had to do the separate parts. We had to take the e to the minus 3s out, and toss in that Heaviside function. So you can bet on your next exam that I'll have you do something with a Heaviside function or a unit step function, because I say next exam, maybe just this the last project from this module 6, but it takes some work. You have to think about it to do it, and that's what I want you people to do, is try to think about the differential equations and how to solve them, and sometimes how to solve them. You have to learn a bit about the surrounding syntax and what's going on. And here it mattered a lot in solving this to begin with, that I knew that unit step function and Heaviside function are essentially the same thing. So I could search for both, and it turns out both existed. One worked, one didn't. And so you could say, well, that's a technology thing. Well, no. That's a math thing. You need to have that vocabulary to know that there are different names for things. So it's a matter of also working on that vocabulary, and that's true whether you use technology or not. And that's sort of a success pulling this together. But this last bit was very unautomated in many ways. It still did a lot of the calculation for us, but it'd be nice if it could have just done this inverse Laplace transform up here to begin with. But no, we have to do a little more ourselves. So again, we have to actually know something about solving these differential equations. Technology is not to the point where I can just say, oh, go do it, and it does it no matter what. So, in some ways we did a better job solving this than Sage was able to do.